Welcome back. This is the third session for the laws of indices, and we're going to look at now fractional indices. An example here, you have a power m over n. You need to understand. See now, our indices now, m over n, it is in fraction. What does it mean? And this is how we interpret this. This is the same as the nth root of a, then we power everything by m. So a fraction indices, the one that is denominator, it is usually the root of a certain the number that have been given there. So an example here, we have maybe a number like 27 power a third. So this one means that this is the cube root of 27. This 3 here, being the denominator part of the fraction, is denote the root. So if it was n, 1 over n, it is the n root of 27. Now because it is 3, it is the third root, which is of course the cube root of 27. And of course this is going to give us 3. And another way of maybe representing that one is to write the 27 into the base of 3. Get 27, you know, that is 3 power 3. Then you multiply by power a third. And this, of course, you're going to get it as 3. So it's just another way of looking at that. Another example here, 25 power minus a half. You have to evaluate 25 power minus a half. Now, previously we have looked, when we have the power being minus, it means that you can just get that one as the reciprocal. So you can write 25 power minus a half as this is equals to 1 over 25 power positive a half. And when it is like that, then you need to just evaluate that. Now, power half, it is a square root of the 25. So this is the same as 1 over square root of 25, which of course is equals to 1 over 5. That's how we go about solving that kind of equation. I can have another question here. Simplify So you have to simplify that question. Cube root of 27 x cubed y power 9 all over x power 6 y power 3. So the first thing is maybe you can just first work out on what you have inside here before you open the cube root. So I can have 27 the same as 3 power 3 times x power 3. Then this is division sign. So and we are dividing from the second row of indices. We subtract the powers of the indices. So x power 3 divided by x power 6. Of course I get 3 minus 6. And then y power 9, and then this is divided by y power 3. They have the same basis, so I just subtract the powers, minus 3. And then this one is under the cube root. This I'm going to get as 3 cubed, then x minus 3 minus 6, that is minus 3, then 9 minus 3, that is y power 6. Then this cube root here, we have said we can write it into fractional index, where it's going to be a third. You can just go backward on the right side. So in another case, we are multiplying everything by a third. So 3 power a third power 3 times a third is going to be 3 power 1. Then minus 3 times a third is x power minus 1. And then you have got y power 6 times that, you get 6 times that is y power 2. So that's our answer, but of course we can write it in another form, because we have this being minus there, and then whenever it is minus, just like doing the reciprocal. So all, we can say 3y squared all over x. This reciprocal, to make it positive, we write it on the lower side or the denominator side. So the two of the answers are okay. Then let's exercise more on this. I have another example here. I have 2 power x plus y is equals to 16, and 4 power 2x minus y is equals to a quarter. This is a simultaneous equation, and we're going to solve the same. Of course, we're going to apply the laws of indices. So in our first equation here, we have 2 power x plus y is equals to 16, and for us to apply the laws of indices, we need to have the basis being the same. So we can write this one as 2 power x plus y is equals to now 16 in the base of 2, that is 2 power 4. 2 power 4 is equals to 16. And then in this case, you have 4 power 2x minus y is equals to a quarter. You can have the basis being the same, because this is a 4 power that, this is 1 over 4. And of course, to make 4 being on the other side there, you can just have it like this. 4 power 2x minus y is equals to now a quarter. Reciprocal of that one, of 4, should be 4 power minus 1. So a quarter is the same as 4 power minus 1. Otherwise, introduce when you want, because this is 4 power 1 here, I want it to be on the other side, and then I find the reciprocal, I write it like that. Now I can be able to see that in our first equation here, the bases are 2, 2. Then I can drop them, I'll be left with x plus y is equals to 4. Then on the second equation, all the bases are 4, or you can make them 2 if you wish, no problem, but it work when it is 4. So because the bases are the same, now we can work with the powers. We can drop the bases. We have 2x minus y is equals to minus 1. So we've got a simultaneous equation here, and we can solve it using various methods. And the simplest of all here, it is the elimination. You can eliminate y by adding the two equations. So you have x plus 2x, you get 3x, then plus y minus y, that is 0. We eliminate that y, and then 4 plus minus 1, that is positive 3. Then we divide by 3 on both sides, we get x is equals to 1. And then just so for the y on the other side, So you can take the first equation, x plus y is equals to 4, and of course we have our x is 1, so 1 plus y is equals to 4, so my y then will be 4 minus 1, which is going to give us 3. So we have solved for that one, where x is equals to 1 and the y is equals to 3. That's a very nice question. And lastly, I can look at another question to just have a clear picture of the laws of indices. Okay, you have to solve for x and y. In 3 power 2x minus y is equals to 27, and 4 power x divided by 16y is equals to 1. So in the numerator we have 3 power 2x minus y is equals to 27, and we need to write the 2 into the same base for us to apply the laws of indices. So in this case we can have this being as 3 power 2x minus y is equals to 27 to the base of 3, that is 3 power 3. And then when you come to the second case here, you can write all these numbers into the base of maybe 4 or 2 if you wish. Maybe you can just use the base of 4. So you're going to have 4 power x, and then divided by 16, that is 4 squared, for 2y, then 2 times y is equals to 1. Is in the base of 4, it is going to be 4 power 0. We said previously that any number power 0 is equals to 1. Now we have this scenario here. The second row of indices of when you are dividing, you subtract the power. So you can have 4, then x minus 2y. Because of this division, you subtract the powers, is giving us 4 power 0. And then that's the equation 2. Equation 1, we have it as 3 power 2x minus y is equals to 3. Now, we have the same basis, so we drop them. We are going to work with the powers here. We have 2x minus y is equals to 3. And then from this second equation, we have x minus 2y is equals to 0. So we have got our simultaneous equation here again, and you can solve it using various methods, and maybe you can use the substitution method, because using the second equation here, you can have x is equals to 2y. We take minus 2y on the other side of the cosine, going to be plus 2y. Then when we use this equation, we go to the first equation there. We have 2x minus y is equals to 3, and then we replace x with the value 2y. So here, instead of having 2x, we have 2. Our x is 2y, then minus y is equals to 3. So 2 times 2 get 4y minus y is equals to 3. Then 4 minus 1 is 3y is equals to 3. So divide by 3 on both sides, you get y is equals to 1. And when you get that, then you need to get a value of y, of x. So x, we have said, is equals to 2y. And then 2 times y is 1, which is equals to 2. So my values of x is 2, and then y is equals to 1. That's how we can be able to form and solve this kind of simultaneous equation using the knowledge of indices. Otherwise, thank you very much for your time.